and Adam is going to tell us all about this. So please welcome Adam Hicks.
Thank you. Cheers, everybody. I'm Adam Hicks. I've been working at Luno for 2.5 years as an engineer, and today I'm going to talk about Luno's growth over the last 8 years and how leveraging Go has made that possible. So we're going to start with a little intro to Luno, and we're going to talk about what we do and how we're doing it. And then we'll talk about why do we choose to use Go, what it was designed to solve, and what makes Go such a good language for back-end development. I'll take a deeper look into a couple of specific use cases where Go's helped us resolve some specific problems when we've been growing our team and our business. And then finally, I'm going to talk about what's coming next for Go and for Luno. So Luno, we're a cryptocurrency wallet platform. I've spoken to a few of you downstairs and told you all about it. But we have a few different cryptocurrencies available. We have Bitcoin, Ethereum, and a few others. And our goal is to give everyone access to this new global financial platform across the world. So we have offices in every continent. Our company started in South Africa and has grown since then. It started in 2012, or 2013. And we have offices in every continent, but actually we're working remotely a lot of the time now. On the tech side of things, we're organized into fleets and pods, and we're very product-focused. Our teams are very cross-competency, and our back-end engineers, we've probably got like 2 or 3 back-end engineers in each pod, and they're given a lot of freedom to solve that pod's problems. And then within the fleets, we have a few pods organized which are focused on a specific product for Luno. So our industry, the crypto industry, has a lot of common challenges and some of the more unique ones. Our customers need to get money into our app, so they have to do that. We have to have banks in lots of different countries. And banks in the UK, as we've seen, are quite sophisticated. Banks in Africa are a little bit different. A lot of the integrations that we have with African and other banks around the world are using sort of legacy integrations, things that aren't very robust, whether it's like CSVs, downloading your transaction statement with a CSV, or even just loading the portal and doing a web scrapers to get your transactions out so you can assign money to customers. We have one bank in Nigeria where we were actually using CSV downloads to assign deposits to our customers and withdrawals. And they decided that instead of representing debits as a negative number, they'd remove the negative number and put it in another field. So every customer withdrawal was now recognized on our system as a credit, which wasn't ideal. We have a couple of recon processes, so we caught this after a day or 2 and limited the impact, but it's just an example of how things can change. Some of our other challenges are with blockchains. We do things like managing keys and wallets on different blockchains and different coins and different purposes, so we have to have separate wallets maybe for sending and receiving and managing the flow of funds between those. And we have to monitor those blockchains and keep them up to date so that we're keeping our customers safe from any changes or vulnerabilities in the nodes. We work in some countries that do have regulations for crypto, but they're currently changing quite a lot. So we have to build systems to adhere to those regulations, and because they're changing, that means that we've got new requirements every day. And we also have to deal with a lot of fraudsters, people that are trying to scam our customers out of money. And so they're constantly changing their techniques and how they attack our customers as well. So we've got to build systems to protect them. And these problems are only going to grow as we get hundreds of millions of customers and tens of hundreds of times more activity on our platform. So here's a little bit of why we're using Go. This is our architecture. Nothing groundbreaking, but we're using over 100 microservices, which our developers are deploying daily. We're built on AWS, and we use Aurora for MySQL and S3. We use other technologies such as etcd and Redis. And this is a graph of the lines of Go code that we have had in the last sort of 8 years. We're currently sitting at about 2.2 million, although, to be honest, this was taken just as raw lines of files, so pinch of salt there. It's not actually operational lines, but it's just a sort of indicative of our growth. We've gone from 10 Gophers 3 years ago to over 70 now, and we're expecting to potentially double that in the next sort of 3 to 5 years. So back at the start, why did we choose to use Go? I put up a list of things here. They were from a talk from Rob Pike in 2012 when he was releasing Go. And I guess you could say the opposite of these is why Go's good. And we've certainly seen that with rapid builds and controlled dependencies. I think our longest build has 940 imports, and it still builds in less than 2 minutes. That's including like tests and packaging. So that's less than the time to make a coffee. And most of our services build in less than a minute anyway. We've got great visibility on dependents. Obviously, we put our go.mod and some in version control, so we can have reviews and make sure that if anyone changes them, we've got at least 2 people that can verify that the things that they're adding make sense. So I'll talk about some of these other ones as well and how they've benefited Go. I think we're all pretty familiar with them, but I'm going to have some specific examples for those. So the first one there, which was about simplicity. I see it as the simplicity of Go, as in like everyone's using the same subset of Go, the way Rob described it. And we saw that when our teams were growing and dealing with different challenges, whether it's sort of new rules and new regulations, as we add more regions or more users, and having to change our architecture to support the performance for those new users. Whenever our developers would be integrating new HTTP APIs or creating new state machines in MySQL or consuming events, what we saw was, because they're all using the same subset of Go, we saw the same patterns emerging. So from different teams, we'd see the same patterns of Go, and that meant that it was really easy for us to justify making packages and code generation, which I'll talk a bit more about later, for our developers and helping new developers who don't have to deal with these sort of solved problems, and we can make libraries and code generation that makes it simpler for them to get started and not have to worry about these things. So as we were scaling, we needed to hire more developers, and talking about the way that Go is easy to read, we've actually been able to hire developers that have no Go experience. So that's really powerful in itself. We don't actually have to onboard people that have Go experience. We can have them up and running and putting code into production in less than 2 months, sometimes less than a month. Because we can have a sort of 2 to 4 week training exercise where they do something similar to the Go playground, where they're writing a playground-like service that interacts with databases and microservices, events, and data migrations to get them used to the language and specifically to Luno's patterns. So that meant that at the end of that 2 to 4 weeks, that they could start going into their pods, dealing with the smaller issues, maybe fixing some bugs, and then very quickly move on to sort of designing systems themselves or adding new APIs and new features. Continuing with Go being easy to read, we require all of our changes to have code review, which in some languages we've had a lot of trouble with. It would be quite slow because it takes a bit of effort to review like complex code. What we found with Go is it does add obviously overhead, but we can do it because a lot of developers are looking at the same kind of code regularly. So if we've got people in other teams, they can even review code for teams that they're not so familiar with, because the patterns get out the way and they can more easily see what's going on. So that's meant that if we've had people on holiday or we've had people leave, they haven't had as bigger impact on the development cycle. The reviews that were taking longer could be solved by another developer. And it also means that we can have developers moving between pods. They can pick up the new work in the new pod, and someone else can pick up their work in the old pod without impacting delivery. And it also means that developers are spending more time working on solving the problems rather than worrying too much about how they're writing the code to do it. We had an example of this. We did have one attempt to write a microservice in Ruby. We had it up and running, and the person that had written it or had written the project left the company, and we had to actually abandon that service and rewrite it in Go. And then from then on, we were just like, nah, we'll just use Go. So that's been really powerful in being able to power the growth of our team. So moving on from that, we decided that we needed to use microservices. Our system grew in complexity, and microservices solved a couple of problems for us. We had a lot of packages that were intertwined, and it made things very hard to refactor. You'd be changing one thing, and another developer would be changing other things related. And your review would then break when they landed theirs. We wanted to scale our database, and we could have scaled the whole database, and it would have been very expensive. But we only needed to scale specific parts of it. So by breaking it apart, we could have separate ones which we could make larger and ones that we could make smaller and save on costs. And that goes the same for the microservices themselves as well. So how did Go help us here? So Go itself, obviously writing the microservices in Go, and these microservices needing to communicate now, we use gRPC for the obvious reasons: great performance, scalable. It's got a proven track record. And we really like the fact that we could upgrade these microservices with zero downtime. We could add new features, add new APIs, refactor things, take things away, and we could do it all without ever affecting our customers. It also meant that the teams could own these explicit interfaces, gRPC protobufs. They would write these interfaces, and it gave them ownership and very clear sort of documentation on what their team is owning and what they're building. We also integrated a lot of the monitoring from gRPC, which is really powerful in detecting issues and finding out when things are going wrong, which is really helpful for the team to own as well. We decided to adopt a pattern that's made popular by Netflix. Well, that's the first time I saw it, where we would have client libraries sitting on top of our gRPC clients, which made it really easy for our developers to build with. We could see these sort of more native Go structs rather than the types that protobufs typically use. So for instance, converting from whatever the Google timestamp protobuf format is into a Google time struct, making it easier for developers to understand and use the messages and the APIs. And it also meant that we can convert things like decimals and financial sort of types into more familiar ones that we've written packages for. Another benefit to this pattern of using client libraries was that all of our microservices, all of the clients for a microservice would access that server in the same way, so we could scale that service in a way that was predictable. If they're all using it the same way, then when there's more load, we just expect the pattern to stay the same but scale larger rather than changing in the dynamic of what data it's accessing and how it's accessing it. For instance, if we had one server that was serving up orders or quotes for a customer, and it needed to page them, or you could stream them. If all of the clients are using the streaming interface, then the pattern in the streaming sort of connections would be growing at the same sort of scale. This led us to integrating events into our microservices, which we ended up developing a library for both producing and consuming. This library is called Reflex, and it was actually presented at the last GopherCon. And what it does for us is it allows us to easily consume lots of different events and set up lots of consumers running in different Go routines. And we didn't have to worry about any of the concurrency. Go manages it all for us. We don't have to worry about matching the number of threads to make sure our instances are fully used. We can just set up all of our consumers and send them away, and we get the performance and robustness that Go provides for us. So moving on to the next section, wanted to talk a little bit about Gogenerate. We've created quite a few tools using Gogenerate, or that use Gogenerate. And if you're not familiar with Gogenerate, it's you can build your own tools that inspect your Go code and generate out files which do specific tasks for you. It's built into the core language, and it's really powerful and encouraging to developers that need to solve the same problem the same way multiple times over. One of the first things that we noticed was when we were adding new features and adding new teams, building new things, they were all creating lots of different tables. And each of those, so MySQL tables, each of those tables needed a Go package, which was going to contain all the queries and run all the SQL code for those tables. And we found that all of our teams were writing this same code. So we wrote a tool called Glean, and it's just a simplified ORM. And the way you use it is you just put your column names into the annotations of the fields. The tool reads those annotations when you run it with Gogenerate, and it creates the query code for converting your rows from the table into structs. So you end up with a function that returns the actual struct rather than anything SQL-y. That allows you to hide potentially like null values, so you don't have to have things like null strings and check whether they're populated. You can just default them to empty strings and 0 values. You can hide SQL errors and turn them into more business logic errors. So you can have explicit sort of quote not found errors, for instance. And I think for our developers, it was really powerful because once they'd seen these annotations and this generation, it was quite clear to them how they would use it. Once they'd seen that they just needed to put the columns and the right types into the struct, then they could use it, and they didn't need to ever look at creating query SQL code again. We could also combine, so because this came after a few teams had already created that SQL code, we could combine all of the nice handling and the nice gotchas in the different sort of implementations into this one code generation, which meant that we were safe from more common mistakes like SQL injections or checking for database connection errors. And our developers didn't need to worry about missing those or being caught out. So we use this on hundreds of different tables now, and we have millions of queries going through it, and it's been tried and tested, and our developers are using it every day. Ooh, missed one. Yeah, that one. So part of our gRPC and converting in our client packages was converting from protobuf types in gRPC into structs for the API. So you'd have a protobuf with your strings and slots in your message. And what you'd want to do is you want to convert that into a struct so that the client can easily read it and get the right fields out in the right data types. So the way this one works is it also has those annotations, the same as Glean. We've called it proto-CP. And it reads those annotations to convert between the message slots in the protobuf and the fields in this struct. And it generates a simple function that will read the struct and convert it into a protobuf or the other way around. This meant that we could make sure that those conversions between things like decimals and times that I mentioned were done to the right types, things like timestamps and protobuf types. It means that all of our developers are using the same types for the same types. They're using the same message types for the same Go types. And it also means that we can simplify nested objects, arrays, and dictionaries so that our developers don't have to write complicated conversion functions. The other thing we could have done here is we could have used reflection, but with generation, you end up with raw native code, which runs a lot faster than reflection. And these messages are being sent around, in your microservices a lot. So it's really valuable to be able to optimize them and reduce the load on your services by making the code that they use to serialize quicker. It also allows us to do quite nice backwards compatibility for zero downtime. You can see in the available field, we've got 2 slots there. We've got the 4 and 7. And what that means is that if you're adding a new, or if you're changing the protobuf type for that field, you can specify 2 different slots so that you can populate both, and it will take the first one, the 7. Or if one of them is null, it will just take the one that's actually populated, which means that you can do this easily and then upgrade your fields to new types. So for instance, we actually switched our decimal types from using a string format to using just a byte binary format, which also helped with serialization because it was much faster. And we could do that all without having to affect too many developers because we just needed to generate their code again. We use Gogenerate in a lot of different places. Here's just a few examples. We've got, I think, probably between 10 and 20 tools that we use to generate code at Luno for different reasons. Not all of them are open source, but in fact, no, none of them are. It's the Reflexes, that is. But yeah, these are the tools and then the patterns that we saw at Luno that really helped when we started using generation. It's made our developers' lives easier, and it's made the standards that we needed to implement implicit and accepted. Another thing we noticed with our code reviews is that we'd end up having the same problems where someone was noticing that the error wasn't handled or the log message format wasn't the way that we decided we were going to do log message formats. Not a big issue, but when you're reading through a whole list of logs, it's nice to have them looking similar so that you're expecting things and you're looking through a trace and the logs look very readable. You can almost read them one for one. So we'd noticed that those sort of comments on reviews were happening a lot. And it would mean that once you've had that comment, the person that's left that review would then would have spent that time reviewing the code and noticing these simple errors. And the person that's written the code has to spend the time to update and then send again for another review. So by running commit hooks and running our own linters, which is also similar to Go generation, where we're processing Go code and trying to parse to see whether certain rules were broken or not. The linter would read that code, read the changed packages, and if any of the code broke the rules, then it would throw an error and it would cancel the commit, and then output a log message saying what the developer needs to do to fix it. So we can also avoid developers using different packages for the same purposes. So we implemented our own error package handling, so our own error package, and that's been open source, that one, Jettison. And what we didn't want to happen was for the things that we thought were happening everywhere, we didn't want them to be accidentally ignored because someone had accidentally imported the wrong errors package. So we added a simple lint that meant that if you'd imported errors, it would say rather use Jettison errors. We could also do that for things like testing frameworks and testing packages so that when you switch between teams, you get the same expectations using the same APIs. We also run the Go provided tool, Go format, and a few others. We've also run those on commit hooks, and it means that those sort of issues are dealt with up front. So Luno is still scaling. We're adding lots more features. We're hiring lots more developers. And we're definitely getting a lot more customers. And we've got a lot more activity on our platform. We're going to keep growing. And I think we're really happy with Go. And it's solved a lot of problems for us. And it's opened the door for us to continue with our growth, which we're super happy about. We're happy that we've got a community here. We're developing a team that's focused on creating tools for developers. They'll be sort of purely focused on internal work, creating tools that simplify developers' lives, removing tedious tasks, and meaning that developers can spend more time building the good stuff. And there's a couple of incoming Go features we're pretty excited about. Generics could potentially either replace some of our code generation or open the door to, well, not generation, but like open the door to patterns and libraries that we couldn't solve another way. We are hiring, as everyone is. We've still got our stand downstairs. We've still got some Lunofers as well. And so, yeah, come see us, check out our website, check out our repos, check out mine. And apart from that, thank you for your time. And I hope you're also having the same experience with Go that we are.
What? Well, thank you so much, Adam. That was really good. Thank you very much. Give it up again, Adam.